This is Algebra 2. I'm recording this outside of the classroom, so it's going to go a little bit faster than I normally go. We are doing 7-1. Welcome to your new unit. We are doing interpreting exponential models today. Our objective is to identify forms of exponential growth and decay and determine how time affects the scale factor. So this is your general formula. I'm just choosing random letters over here. I chose a capital E, it could be a capital P, capital whatever, it doesn't matter. And I chose a random variable, T, it could be N, it could be whatever. This is the main thing that you need to know. For A, this is your initial value. Initial value. And if you don't like the word initial, you can think of this as your start. How much did you start with? So maybe you have a petri dish that has 2,000 cells of a certain bacteria. Well, your start amount is 2,000 cells. So your start value or your initial value is A. All right, this B right here, and this is B to the power of T divided by time. It's a little bit harder to see in this form, but this B is your base value. So I can call it the base, but really it's known as the scale factor. Scale factor. Sometimes I'll refer to it as the word the base, because that's what it is in terms of an exponent. You have the base and then you have the power, so base. And then you always have some exponent where the variable is in the exponent. So I'll make a note, it is kind of important, that the variable is in the exponent. That is what makes a function an exponential function. You don't have some x to the power of 2 or some t to the power of 3. These had the variables in the denominator, but now we're not doing that anymore. Now we have a number for the denominator, and the variable is going to come up here. So 2 to the power of x or 3 to the power of t. These are exponentials. These were simple polynomials. This would be a quadratic and then a cubic. So notice that the t is in the exponent. So I'm going to get rid of all that. We don't really need that. The other thing to note is that time is in the denominator. And this is not 100% true. I'll be clarifying this later in the lesson. But notice that time is in the denominator. So units of time. If you ever see a unit of time in any of this unit, if you see days or years, automatically it cannot be A, it cannot be B. It's something to do with the exponent. And where to put that, you're typically going to be putting it on the denominator for the exponent, but I'll talk about that more in depth later. So let's move on. What do I mean by growth and decay? So growth means it's obviously getting bigger. So I want to think of this as a positive value. I'm getting bigger and bigger. And decay, I want to think of this as getting smaller and smaller and smaller. But you never actually are negative, so maybe these symbols are confusing. Maybe I shouldn't put those. But growth maybe is going up, decay is going down. Maybe arrows are probably a better way of saying that. So exponential, I'm going to choose growth. Exponential growth is when, okay, and then is it A, B, T, or time? I have 4 different options to put in this blank. And is it going to be bigger or less than 1? A will only affect the initial value. You don't know if you're going up or down, just knowing the initial value. I don't know what's happening every 3 seconds. Am I going up or down every 3 seconds? That's your variable. That's always going to be the variable. So that by process of elimination, it needs to be B. So when B is going to be a certain value. So if it's growth, it's going to be bigger than 1. Not bigger or equal to 1, because if it's equal to 1, 1 times 1 times 1 is just 1. So it needs to be strictly greater than 1. And then on the flip side of that, exponential decay is when B is greater than 1. And I know that there are some of you that are thinking, well, wait, what just happened here? Decay is less than 1. Ugh, sorry about that. Exponential decay is less than 1. And I know some of you are thinking, wait, isn't negative 2 less than 1? Yes, I was assuming that we are always going to have a positive amount of scale factor. So I'll make a note here that typically speaking, your scale factor is going to be greater than 0, which means that you can't have any negatives. And that kind of makes all of this now very formally true. So this is probably the most confusing thing about today's lesson, is there are two ways of saying the exact same thing. So I just chose kind of a random function here and a random function here, but the question is asking for different things. One of them is asking for a factor. The other one is asking for a factor as well, but this one is being added. I was looking down here too far. So the difference between factor and added. You'll always have like a drop-down menu down here where you can choose between like added or subtracted. You can choose between grows and shrinks. In that drop-down menu, you'll need to choose one of those, and that will affect how you proceed to with the rest of your math. So if you ever see the word factor, 100% of the time, every single time, this always means just copy this down verbatim. It's nice and easy. So if it's a factor, the factor is always going to be that value right there. So the factor is, in this case, 1.25. 1.25. Nothing fancy. And this will apply to the rest of our lessons too in 7-2 and 3. If you ever see the word factor, it's the easiest possible question. Okay, now, and I guess I should point out here, notice how this b, this is the b, right? This is greater than 1. If it's greater than 1, then it's growing. So that's why I said grows here. All right, so grows, these two words kind of link up. So grows and added, those two match up with each other, just like shrinks and subtract. Those two go with each other because I'm going smaller, so I'm subtracting. I'm shrinking, I'm going bigger, so I'm growing, I'm adding. So what percent is being added to the total in this case? So in this equation right here, what percent, this is the question right here, what percent is being added to the total? Whenever you have something that's dealing with the words like add or subtract or anything that remotely even means that, add or subtract, we always need to compare this to 1. And I feel like I just lost some of you. So compared to 1, what do I mean by that? Let's see, if I just said this was now the equation 123 times 1 to the power of t, no matter what number I plug in for t, this is going to be the same amount. 1 will make it so I don't change because 1 to the power of 2 is 1 times 1, which is 1. 1 to the power of 3 is 1 times 1 times 1. No matter what value I choose for t, even if it's a decimal, nothing's going to happen. It's still going to stay the same value. So I always want to compare to 1. 1 will give me my same answer. 1 is 100%. I haven't changed at all. I'm not going up. I'm not going down. I start with what I had. So that's a long-winded way, I apologize, of saying just compare this number to 1. Oh, check it out. This number is 0.25 bigger than 1. That's why I'm adding to it because it's bigger than 1. So I'll say this, 1.25. If I subtract 1, 1.00, I'm left with a decimal, 0.25. And then I need to convert that into a percent. So 0.25 as a percent. The rule for percent is always move the decimal twice to the right and then say, oh yeah, that's a percent. So 25% is the correct answer. All right, so our new equation. I just chose another random one. Now that is going to be shrinking. Why is it shrinking? Because that number is less than 1. Therefore, I'm going to be subtracting something in order to get the decimal 0.89. Well, if it says the word factor, again, I told you, if it ever says the factor, just copy it down, 0.89. If it says subtracted, if I use the word add or subtract, anything like that, always subtract 1. So I'm going to say I originally started with 0.89, subtract 1, 1.00, and I can't really do that. I mean, you can use your calculator if you want. You can be like, oh yes, I pull up my Spotlight search, 0.89 minus 1, I get negative 0.11. Yes, that is the correct answer, negative 0.11. How do you do it if you just had paper? Well, then you'd switch these two. You say 1.00 minus 0.89, and then I would just know that the answer should be negative since I'm taking away 1. And then I have to borrow, that turns into a 0, that turns into a 10, borrow again, that turns into a 9, that turns into a 10. 10 minus 9 is 1, 9 minus 8 is 1, so 0.11. So again, this is a decimal, I need to convert it into a percent. So this is now going to be moved twice, make it into a percent, so it is now 11%. 11% is being subtracted from the total to get 0.89. All right, so from there, let's move on to example number 1. So we have an equation, and that is representing the population of wolves every t months. Every month, the wolf population is it growing or is it shrinking, first of all? Is this fraction, is that bigger or less than 1? And as your hint in terms of fractions, if the top is bigger than the bottom, then that's going to be greater than 1. If the top is smaller than the bottom, and I'm using capitals to let you know that the bottom is bigger, then that's going to be less than 1. So an example of that is like 1, or like, 2 over 3. That is less than 1 because 2 divided by 3 is 0.666 repeating. When the top is bigger, something like, 7 over 6, you can see that when I do 7 divided by 6, that is definitely bigger than 1. It's 1.6 repeating. All right, so that is another long-winded way of saying that this number is less than 1. So therefore, if it's less than 1, I come back up here to my definition. When it's less than 1, that is decaying. I am having that shrink. Shrink is the word I'm looking for. I'm going to circle the word shrink. And by what factor? If it says the word factor, you just copy down that word right there. It's 5/6. 5/6 and done. For example number 2 now, we have another equation, capital M, and it has that equation, represents the amount of money in the stock market every T years. Every year, what percent of the total money is either added or subtracted from the total amount of money? So we'll do that first, and then we'll go and answer the second question here later. So what percent is being added or subtracted? Well, let's first add or subtract. What are we doing? Is this bigger or less than 1? Well, it's bigger than 1, Mr. Sindel. It's 1.2. It's 0.2 bigger than 1. So if it's bigger than 1, it's therefore being added. We're adding to 1. We're always comparing to 1. And then how much are you adding to 1? Well, I'm adding 0.2 to 1. And this is another way, like the long way of saying, okay, I have the factor of 1.2. I subtract 1.0. I get 0.2. And then from there, I need to move the decimal once and twice. So that means I actually have 20%. So every year, 20% of the money is added to the total amount of money. And then I can answer the second question. Every year the money either grows or shrinks. Well, we know it's grows because it's bigger than 1, so I can come down here and say, yes, it is indeed grows. By what factor? Oh, it used the word factor. Whenever it says factor, you just copy down whatever's there, 1.2. All right, and then finally, that's one assignment, right, on Khan Academy. Now we're on to the second assignment, the second part of our objective for today's notes, which is to interpret time. So let's just give you an equation. Here's an equation that's going to model the temperature of water cooling off every T minutes. So I want to know, what is the temperature difference? It's reduced by a factor of 3/4 every however many minutes. And notice that it has factor, it says 3/4, 3/4. Okay, everything is matching up so far with what we should be doing. But every how many minutes? And the answer is always the denominator. And that's the very short, concise way for this entire homework assignment, and you'll be good. But I'm going to teach you a little bit more than that, because in the future homework assignments, this is going to get really confusing. Do I put it on the top or the bottom? What does it mean when I have something that's like 3.2n where there's no bottom? What does that mean? But again, simply whatever the bottom is, that's the answer. It's every 3.1 minutes, because in our equation up here, your time is the thing that's in the denominator of the exponent. Hopefully now you are asking yourself, or me, why? Why is that the answer? And let me explain. So why is the time in the denominator of the exponent is the question? And really what we want to be thinking about when I'm thinking of this equation is, what value should this variable t be? So the variable, I can say the variable, or I can just say t be, in order to have the desired scale factor. Well, my desired scale factor, I said right here, my scale factor needs to be 3/4. So in order to have 3/4, this 3/4, I need this to be 3/4 to the power of 1. How do I make this thing 1? And that's always the question. So I'll rewrite the question another way. So if I say, the other question you could be thinking is, how do I make the exponent 1? If you can make the exponent 1, you've achieved your goal. So what value of t right here would I plug in? And I mean, it's the same answer, right? What value of t would I plug in order to make this value right here 1, and therefore make this scale factor 3/4? And the answer is, oh, we'll just make sure that if t is equal to 3.1, then I'll get 3.1 over 3.1, which is equal to 1. And I have achieved my goal of making the exponent 1. Okay, well, what about this one? How do I make this exponent 1? Well, it's the same answer. If t is equal to 6.9, that will make this exponent 1, because again, I'll plug in 6.9 into the numerator. Go away. And then the denominator is still 6.9, and therefore that's equal to 1. And that seems pretty straightforward. Oh, Mr. Sindel, just choose the bottom number. Here is where things get tricky. What if I just gave you this? In the future notes, that's what I'm going to be doing. Well, what do I need to multiply 3.2 by to get 1? What number should n be in order to get this exponent to be 1, and therefore multiply by a scale factor of 0.79? The answer is 1 divided by 3.2. So check it out. I'm going to rewrite the 3.2, and if I plug in a fraction 1 over 3.2, 1 over 3.2 is the answer for n. n is 1 over 3.2, because now I can cross cancel, and this is exactly equal to 1. So my n that needs to, I'll write this out. My n value that I was actually searching for is 1 over 3.2. And same thing down here. What value of t should I be plugging in order to get this whole exponent or this to have a scale factor of just 2 instead of 2 to the power of 1.5? Well, I need to multiply by 1 over 1.5. So t in this case needs to be 1 over 1.5. And then I'm multiplying by a scale factor of 2. So I can boil all of this last part of the lesson down by saying this. Take the reciprocal of whatever number is given to you in the exponent, and you will be able to get your desired scale factor. So reciprocal, by that I just mean flip. I had 1 over 3.1, I flipped it and I got 3.1. I had 1 over 6.9 and it turned into 6.9. I had 3.2 over 1 and I flip it, it becomes 1 over 3.2. I had 1.5 over 1 and I flipped it, it became 1 over 1.5. So that is your quick and easy way to do this type of homework assignment or any type of problem like this on Khan Academy. That's all I have for you guys for Algebra 2 Notes 7-1. Thanks for watching.